Hi, this is the material to understand the area of the circle and to derive the formula for the area of the circle. Now there is a board with circle cutout and a rectangular cutout or a slit under the circle. There is a box full of foam pieces. Now, area is the space that the circle occupies. Now, there are these pieces that are there in the box can be lined up in this cutout to form the complete circle. That means these foam pieces can be filled in this place which actually forms the area of the circle, which is what I am doing right now. So I'm lining them up. These are like sectors of this circle. I'm lining them up one next to the other so that they completely fill this area. Now I have 2, 4, 6, 8, 10, 12, 13, 14, 15 big pieces and are all of the same size. And then the last one, the 16th one, is cut into two halves. And we'll know why. Okay. But all of them can be fitted exactly to form the circle. Now, the area of the circle is nothing but the area occupied by these foam pieces. So, to derive the formula, we make use of another formula, which is the area of the rectangle and the circumference of the circle. So, these two things are prerequisite to understand this. So, area of the rectangle is length into breadth, and the circumference of the circle is 2 pi r. So, to the next step is to take out these pieces and line it up in the rectangle given below. And they are lined in such a way that the curved surface of the sector um, is facing the length of the rectangle. However, adjacent sectors are inverted, meaning if one sector has the curved surface facing the length and the pointed side facing the other length, then the second sector next to it is inverted, upside down. Okay, so that is how I line it up, and I see that it completely fills the rectangle, leaving two small spaces along the breadth. Now that small space can be filled by the two small foam pieces. Okay, now when I do that, the complete rectangle is filled. Now the area of the circle is nothing but the area of this rectangle below it. Now area of this rectangle is length into breadth. Length has to be determined now. If we notice, the curved surface of all the sectors are facing both the lengths, right? So uh, they are divided among these two lengths. That means if I just want one length, then I have to take only half the number of pieces that are there. So that means 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Right? The two small pieces. So I have 8 pieces facing one length and 8 pieces facing the other length. So now if we just take one piece and understand, keep it in the circle and understand where exactly the curve comes on the circle, They all come along the circumference of the circle. So the length of that is actually, in length of all of them together, is is actually the circumference of the circle, which is 2 pi r. Now in this case, the length of the rectangle is only half of that circumference, because you have one set facing one length, the other set facing the other length. So two lengths together form 2 pi r, which is a circumference. Therefore, one length is pi r, right? So pi r is the length. What is the radius? If I just pick up one sector, put it again in the circle, I observe that radius is nothing but the breadth of this rectangle. So r is b. So the area of this rectangle is length into breadth, which is pi r into r. So pi r into r is nothing but pi r square. And that is a formula for the area of the circle.